Ladies and gentlemen, I'm very honored to be here with you tonight. And John, I have to say I'm very proud to be here, and I'm also very proud of Sir John Parker. He's one of the preeminent figures on our board, and I can testify certainly that he has also been in the business of breaking down barriers in our own company in the last 5 or 6 years. I just recently read, John, a quote in The Independent, and I quote here, "A man you want on your side and not one to cross," end of the quote. And I can only underline that. He's a man on our side, and I can also say I think the takeover panel will hopefully not object on that you've been very helpful and supportive in this major project that we are currently undertaking. And that is already as much as I want to say in my lecture about this EADS, EAE merger project. Other than that, you've probably seen the little article that Ian King and I today published in the Financial Times, Le Monde, and also some German newspaper. And I think it says it all, captures the very essence of why we think that this project is a great project for both companies. Ladies and gentlemen, 43 years ago, Concorde became the first commercial aircraft to break the sound barrier. Within 8 years, passengers were flying faster than the Earth could turn and admiring its curvature over dinner. Admittedly, I've ever flown with Concorde, but not the most spacious aircraft. Yet by 2003, it was all over. If you compare the golden age of steam, spanned over a century, yet supersonic air transport went from 23 miles a minute to the history books, so to say, in just 27 years. And many people, me included, even though I'm not an engineer by training, were outraged by what appeared to be a step backwards in the history of technology. How could such a thing happen? Well, perhaps the answer to that lies in the true legacy of Concorde. For me, that is not the new era of high-speed travel, not even what we learned in terms of technology and international cooperation, but rather what we learned in terms of a need for more pragmatic engineering. As Sir Bernard Lovell put it, quote, "The simple belief in automatic material progress by means of scientific discovery is a tragic myth of our age." End of quote. In other words, it's not just because the technology makes something possible that it makes sense. Concorde, to be not misunderstood, was an incredible achievement. But while pushing the complex laws of physics to their limit, it failed to meet the rather basic laws of supply and demand. Enormous fuel burn made operating costs and ticket prices too restrictive. People were just discovering long-haul travel and standard flight at the time. And with few big customers, very few big customers for the spare parts, suppliers were tempted to simply stop making them. Today, development costs are usually, Nigel, 10 times what they were for Concorde, and this remains a capital-intensive, long-term industry like no other. So the stakes have never been higher. Just look at the products. The 747 was in service before some of you were born, and the last 380 pilot has yet to be born. What I'm describing here is that it takes sometimes up to 20 years from develop new technology, start the development, go into production. Production lasts perhaps 25 years, 30 years. Again, 747 is a good example here. And that can give you a cycle of 60 to 80 years. Well, there's one example that we're all expecting in the military field, the B-52 bomber. People are predicting will be flying 100 years after many refurbishments. I think these long cycles also explain why the average games console today has more capability than some single-aisle aircraft. This is not to disparage single-aisle aircraft, but it just shows that, different technology moves with different speed here. And it explains perhaps why NASA ended up scavenging chips from old computers on eBay just to keep the space shuttles flying, ladies and gentlemen. And look at operations. Negotiations across dozens of countries mean that upgrading air traffic control is as much about politics as it is about technology. Which is why kids today use direct data links to play games, but we still use VHF radios for pilot-to-ground communications. That is the contradictions with which we live today. Look at research. It can take decades, not just to develop great technologies, but to identify how best to combine them. One example here in the UK, perhaps, the tornadoes, the brimstones the UK used to support Libya were only available because of investment back in the 70s and 80s probably. So big timescales and big investments, but airline profits and military budgets are so small, they need the benefits of tomorrow's technology today. Environmental, political, and security demands can change in a couple of months. And the many other industries that depend on air transport, depend on satellites or cybersecurity, need to remain competitive and safe in a global economy operating to an entirely different schedule. So how do we deliver on all of that? How can we achieve a major turning point? A turning point not just for our products, but for the industrial model to deliver these products. And how do we balance, on the one hand, 60 to 80 year cycles for products with 4 million parts or more, and a world where, on the other hand, expectations change with an 8-minute Apple presentation, just like that? How do we integrate great solutions from other industries and still safely maintain production schedules that assemble the big ambition, one day perhaps aircraft in less than 1 day? With Concorde, ladies and gentlemen, clearly the technology outpaced the demand. And now we are struggling to keep up. Breakthroughs in our industry like laminar flows, open rotors, turbo shafts, biofuels, tactile technologies hold the key. But the right solutions don't come fast, they don't come cheap, and they certainly don't come easy. Which is why, if I may here, I quote our chief engineer at Airbus, Charles Chambion, who constantly reminds our chief salesman that technology can do anything, but it can't do everything. That's a famous saying. There are choices and trade-offs to be made, both in what we want to do and how we want to do it. Because aerospace does no longer set the pace for microchips. But it does still drive the pace of economic and social development on this planet. I think we were all reminded by that a couple of years ago when the famous unpronounceable Icelandic volcanoes broke out and interrupted air traffic in this part here of the world. And how high the costs were. The costs were immediately exploding for our economies, not just for the airlines. And it does still drive engineering and technological advances for the manufacturing sector. Combined with the defense sector, it also supports over 1 million highly skilled UK jobs. And the figure here, I hope it's right. I have so many prominent experts in front of me, so I get a little bit into sweat. 22 billion pounds in experts. That's not just with the big players like BAE, Rolls-Royce, EADS. It's with a network of suppliers who provide up to 70%, sometimes even more, of the product's value. Spillover benefits mean that every 100 million pounds invested in R&D is actually worth twice that to the UK economy. That goes for other economies as well. Rainer, we've done some serious studies about that at Airbus a couple of years ago, and that was one of the interesting things that that came out. And all these benefits, that's just before you even start getting into many other industries, policies, humanitarian efforts that depend on us. So we in our industry, we do connect lives, we save lives, and we make lives better. Or as John Parker put it in a recent interview, John, I saw preparing for this momentous event, we are just one, you said, great big traction engine. And I think that we can certainly say for the aerospace industry. But ladies and gentlemen, sharing the benefits should also mean sharing the investment and sharing the risks. In fact, many of you here today, I guess, are in a similar situation. From engineering companies that could help jumpstart the economy if we get the right support from governments, if we can change attitudes towards engineering, and if we ensure better cooperation between different companies and different sectors. It's not just between companies in the same sector, but I think it's increasingly important to have a better, far-reaching cooperation, starting with technology developments between different sectors. So what can we do about it? Let's start with the government support. Recent survey looked at what 40 nations have done in the last decade to improve their innovation capacity. Both the UK and Europe, that's probably not surprising, were in the bottom half. With Europe already expected to account for just a tenth of the world's economic weight by 2025, that is something that cannot continue. We will otherwise get further and further down. Interestingly, the UK government invests significantly less in aerospace R&D than some of its European neighbours, but according to that survey, it is getting much bigger bang for the buck. It's the third biggest producer of research in aerospace after the US and China, and the second biggest in terms of quality. So there are definitely some lessons to be learned or to be shared in terms of probably spending smarter rather than just spending more. I know I'm on thin ice here because I'm quoting a survey here. There may be other surveys, but I thought my UK audience would like that. You probably get very often treated on everything's bad and it's getting worse, that, you know, we're lagging behind. It looks like in aerospace you're still doing very well compared to others. It sounds also like the Aerospace Growth Partnership is a good example, thanks to the leadership of ministers from the Department of Business, and I should also say Marcus Bryson from GKN. Some of the results explain how the UK is able to redress the R&D spending gap. Wider cooperation with Typhoon partners Italy, Germany, and Spain to share expertise, drive exports for missiles, radar, defense systems. Investment in facilities like the £60 million UK Aerodynamics Centre announced by the government, I think, in the recent air show in Farnborough. The Airbus North factory in Broughton that was opening last year, or was opened by the Prime Minister. New RAF simulators to improve both military and industrial capabilities. And not to mention funding for 500 master degree places. And I found, John, this academy and the Royal Aeronautical Society are doing a great job of ensuring alignment with the partnership's long-term vision. I find that outstanding, as a matter of fact, ladies and gentlemen, also because I can compare what happens in neighboring countries, be it in France, in Germany, in Spain, and that's, I think, an outstanding achievement. And I'm particularly proud that virtually the entire team at our Innovation Works here in the UK, the EADS Innovation Works, are sponsoring a lot of PhDs. This kind of public-private cooperation is vital if we want to make progress. But there's a lot more to do, and certainly politicians have a role to play, but so do we as industrialists. And I think the partnership I was talking about, how's it called, AGP, is a golden opportunity, and we need to grab it as industry with both hands. And I think it can also, to a certain extent, be a model for a closer cooperation in other countries as well. Grabbing this opportunity with both our hands, I think it has to start with changing attitudes towards engineering. Without that, any investment in education, facilities and partnerships will never be fully effective. So we need to attract the right people. We need to persuade them to stay throughout their career. It's one thing to attract them, and I've seen that in many years, but it's much harder to retain them. Well, a few years ago we lost a lot because everybody wanted to become an investment banker. Maybe that is nothing against investment bankers. We have a prominent example sitting here in the first row. But maybe, I see that with my own kids, by the way. There's more interest again in engineering than there was perhaps before the financial crisis. And, ladies and gentlemen, we need to share the knowledge, expertise and passion of the current generation before they head into retirement, before they head to the golf course. And I think here we have a lot to learn from mistakes we made as an industry in the 1990s. At least I can say that for the companies I worked with. We did pay little attention, not enough attention, to knowledge transfer from one generation to the next generation, when we sent a lot of experienced people with age 55 into early retirement, partly because the government was co-funding it. Well, to give you an idea of the urgency, a third of the aerospace engineers in Europe are close to retirement, and I think there are similar numbers when we look to the US. The baby boomers are rapidly getting out of a job. But only 1 in 5 school kids achieve proficiency in the core science subjects. Universities only produce around 3/4 of the aerospace engineers we actually need. And only 40% of them follow non-engineering careers after graduation. When you also realize that just a third of science and technology students are female, and that less than 10% of them are pursuing careers in engineering. Again, government and academia have a role to play in addressing those issues, but ladies and gentlemen, I think first of all, it's our own responsibility. We can show kids why engineering is such a great choice, not just as a career, but as a way to shape the world. By the way, their world out there. For many people, the loss of Neil Armstrong marked the end of an incredible era of progress. Guys like Armstrong or Chuck Yeager went to the moon, broke the sound barrier with less computing power than the smartphones that we all have in our pockets. But they didn't just break barriers to speed or space. They broke through mental barriers to what people thought was possible. And they inspired a whole generation after the war and in the 60s and 70s to work in aerospace and engineering. Well, I'm proof, I'm not an engineer, that you don't necessarily need to be an engineer to be bitten by the aerospace bug. And once you're hooked, you don't want to do anything else. At least that's my fate, as John was explaining the last 21 years. And that's why some of our great engineers, like Jenny Bodie, retired from Airbus, only to end up becoming president of the Royal Aeronautical Society. But now we are faced with a generation who consider it, let's say, trivial, banal, to watch images from Mars. So we've got to find a way to ignite that spark that people like Armstrong and Yeager and others were able to ignite. A lot of things we can do. I found one of our young engineers, Rhys Phillips, has gone as far as setting up a radio show called Pythagoras Trousers to get kids hooked on engineering. But it can also be offering internships. I think that is very, very important to warm up young people, or building school talks into a business trip. Secondly, we can share our expectations in terms of matching traits and abilities. Apprenticeships are a great way. Internships and apprenticeships are a great way into engineering and manufacturing. In fact, when we did a little research in preparation for that speech, we found that this is how Lord Hinton started on the railways as an apprentice. But we need to put the right kids in the right placements for it to work, for them and for us. Like so many aspects of engineering, the quality matters certainly more than the quantity. But the results can be great. One of our 380 customer program directors, Steve Martin, started as an apprentice with BAE here in the UK, and now he passes on that spark, for instance, with kids coming for work experience. So that is done, in parallel to the normal job. And that, ladies and gentlemen, is closely linked for me to my third point, that we can help recognize the real value of engineering and rebuild its standing in society on a par with investment bankers, doctors, and lawyers. And again, John, the Academy is doing a great job of pushing this, but I think there are some easy wins we can look at closer to home. At EADS, we offer engineers a choice of career paths to help retain their passion. They can take the traditional management route or advance, on the other hand, as engineering specialists. We found one of the biggest mistakes we made over years that we forced people more or less to advance in the management and found people that didn't like it. They didn't like the people management. They would much rather develop radars, E-scan radars, or what have you, and that was their thing. But we forced them more or less because we had no career path for experts. We changed that in our company a couple of years ago so that you can be recognized, you can get recognition if you are on an expert path or on the traditional management path. And having that avoids frustrating good people who want to stay hands-on and still develop their career. And it also means we can keep their experience and knowledge where we need it most. And it also means that by taking these people out, bad managers but excellent engineers, we avoid a lot of frustration with our younger people to be led by these people. Interesting work, motivation, pride. Engineering must be one of the few careers that can offer that right now. All of which bring me to the last area we need to tackle, and that is cooperation. Ladies and gentlemen, it's no great secret that there is a limited pool of real engineering talent, resources, or investment. Or that competition and economic cycles can shift even quicker than your great cyclist Chris Hoy on a carbon cycle. Which means that British and European industry need to make better use of what they do have. That means, sounds simple, but that means more cooperation, wherever and whenever we can. My own company, we even cooperate with Boeing on some admittedly limiting areas, but if we can cooperate with Boeing, then a lot of other cooperation schemes are possible, sharing expertise, generating growth, and tackling also the big ticket items like safety or the environment. And this is one area where the people in this room, more than anybody else, I think can make a difference. Just look at the number of different companies, sectors, and countries we cover between us in the aerospace world. We need to make better use of opportunities available through organizations like the Academy or the Technology Strategy Board here in the UK, which I think is also a very fine and important organization to further cooperation. And this board's catapult centers are there to help to drive cross-sector cooperation. So pretty much everybody in this room can help bridge the gap between industry, academia, research, and government. For over 200 years, we've seen regular cycles of economic crisis turned around by a breakthrough in technology. Steam, textiles, steel, rail, jet engines, and microchips were all pivotal. And there's no reason to think the same can't happen this time. Then a whole host of new, you can call them displacement or disruptive technologies are just about to break through with the right support from governments, with fresh attitudes to engineering, and with better knowledge sharing and better cooperation between companies and companies from different sectors. Just one example, take 3D printing. Unfortunately, we didn't invent it at EADS, but we've been able to help adapt it to provide huge advantages for manufacturing, and that'll come in the next years. It will be a breakthrough in manufacturing. And with materials like titanium in short supply, this technology could reduce waste from 90% to just 5% in aerospace production. So that is going to be a manufacturing revolution. But it's hard to think of many aspects of industry that won't feel the effects of this technology. The same applies to things like nanotechnologies, and some of the guys working on it reckon that with chicken wire, thinner than a hair, and lenses smaller than a decimal point, you will be able to collect and share the energy from any window or surface without a crit. Without a crit. Free energy, anytime, any place. It's not yet there, but it's just around the corner. Ladies and gentlemen, when Armstrong died, the Mars Curiosity flight director allegedly tweeted that, I quote, "We will try to carry on your legacy," end of a quote. But if you really intend to go to the moon or break sound barriers or solve energy or economic crisis or inspire a new generation of engineers, you don't try, you do it. And as the astronaut said, failure is not an option. Risks must be managed, but they must be taken, not tried. That means, it's an important point for me, because this is how our societies function today. We try, but the last percentages of commitments are often lacking. We don't try hard enough, you could say, like perhaps previous generations did, with much higher risk, and they knew they had much higher risk. They went to the moon and elsewhere. That means I think we need a debate and decisions on what each nation sees as their priorities, where they will stake their claim for industrial growth, and how they intend to deliver. Don't get me wrong, it's not about national industrial policy, but governments can help with a sound industrial policy to spark, to initiate. And I think Airbus is a great example that will then flourish and expand and become a wonderful international enterprise. Breaking the sound barrier with Concorde was great, but breaking the barriers to education, innovation, and cooperation, and delivering the kind of pragmatic engineering that drives responsible growth, improves people's lives, and captures their imaginations. Now that, ladies and gentlemen, with that I conclude, that I think would be a legacy we all could be proud of. Thank you very much.
Well, good evening, ladies and gentlemen, and thank you, Sir John, and thank you, Tom, for that inspiring and uplifting tour de force. I asked my German friends in Dean what was a better expression, and they said Meisterleistung.
Meisterleistung. Yeah, sounds familiar.
So we're on the subject of European cooperation, and you had some fantastic themes in that speech. But you'll also be sure that in the audience, we have quite a few engineers who are going to determine to ask questions. And I hope you wouldn't mind if we ask a couple of questions about the proposed merger. You talked about the story published in the FT this morning and so on, but just perhaps if I could just tease out some of those issues. Just in very simple terms, what is the proposed combination of EADS and BA systems mean for Britain and for engineering in Britain?
Okay, well, I hope that this was really about engineering and is covering Mars, etc. But let me say, I mean, you find it captured in the article that Ian and I published today. first of all, we think this is a wonderful opportunity because we could build a company that would be not only financially more resilient going forward, but that would achieve a much stronger platform for growth internationally in defense as well as in the non-defense areas that would also benefit from this great company. And I think the point is that we in aerospace, coming back to my product cycles, need to look at things a little bit more long-term. You know, today when we speak about long-term investors, if they hold their shares in our companies 2 or 3 years. Now that is clearly not what we think is the time frame we should be calculating with when we do these kind of things. The benefits will particularly be mid and longer term in, as I say, stronger growth, much better access to international markets. You take the world's premier aeronautic company, commercial aeronautic company, you add the most international defense company together, and obviously that is a proposition that is for both companies very, very attractive, I should say. And if I may say, John, without going into secrets, a proposition that is strongly supported also by the board of my company, because it's a sound strategy. Now, we face the same concerns. Let me put it that way. In France, in Germany, over here, what does that mean? Are you guys slashing thousands of jobs, etc.? That's not the purpose. I mean, this is a. Don't you think I have enough? I have one here, I have one here, now I have a third one here. So is that MI5 or one? Well, I can only say before being drawn into this, because thank God there's a takeover panel, a word I had to relearn a couple of months ago. And it's much recursum sometimes. It's good that you can hide behind them as well. I can't go into details, into figures at this point, obviously. Just to say that I think both companies are very, very convinced that this would be the right thing to do. Would be great for Britain, would be great for the other countries as well. This would be a merger of growth, particularly. As we said today, it's not that we are desperate to do it, but it's a great opportunity for both companies and certainly for the workforce and for the investments that we intend to continue, obviously, in all these countries where we are strongly present today.
And how are the discussions going with government and the others?
Let's put it that way. I mean, the two companies have done their homework. The two companies have agreed at this point what they could possibly agree to. And yes, we are now looking at governments, but it's a very complex undertaking. I should say in aerospace we're used to deal with complexity, but this is a level of complexity that is considerable. So
you wouldn't share with us the main challenges you have?
No, certainly not. But we are intended to come to a conclusion very, very soon. It's clear. You have combined more than 200,000 employees who are hanging out there. What's happening there? You have investors who are reacting very badly. We have customers, and obviously from a company point of view, and Ian and I are completely agreed on this. We cannot. Thanks, Rainer. We cannot go on much longer. So this is why we think that the next 10 days should be decided.
Okay, thank you very much for that. I think we should really move on. But just turning back to your talk, you covered a lot of ground, Tom, and let me just try and remind us a couple of those thoughts before we get into that. You talked about the importance of technology making sense. That's to say you can't do everything, which is a challenge of market relevance. You emphasised the rate of change of market expectation, the idea that things are moving so fast, technological innovation just can't keep up. You talked about the importance of aerospace and defence driving engineering and technological advances that spill over into other sectors. But you gave us 3 conditions. You talked about the importance of closer dialogue between government and industry and changing attitudes to engineering in government, and thirdly, about the importance of cooperation. And then you challenged us, very interestingly, to at a national level, to debate and define what we see in terms of priorities and how we intend to deliver that growth, which is an exciting challenge. And I know that here in the audience, we've got lots of people who already have the answers to that. But just before I ask them to give us those answers, let me just try a couple of questions of my own. Coming back to aerospace, you started with Concorde, and we talked about single planes. What do you think is going to be the next big breakthrough in the aerospace industry?
Well, today, and that is the dilemma that we're facing. I mean, it's not like in the olden days where money didn't matter, so to say. Things were... Concorde was probably the last project that was done also for the glory of countries and engineers. We can't afford that. And it's very difficult to say exactly what's the middle ground. On the one hand, we need brilliant, innovative, creative engineers. On the other hand, we want also engineers to think that not everything is possible and not everything can be funded. And that is a constant, it can be very fruitful, but it's a constant dialogue in companies. The engineers moving into that direction, and the controllers saying, okay, we can't afford it. It's not like the olden days when we were all national companies or something, and profits didn't matter. So profits need to be part of the equation. I think what we are focusing in today, talking about the commercial aviation area, is fortunately or unfortunately not that terribly inspiring like a Concorde project, but it's about making flying more environmentally friendly. That is about fuel consumption, that is about noise. But if you look at our societies, I mean, if we want to keep up the growth of the commercial air traffic, it is absolutely inevitable we are able to bring answers to these challenges, because all of our societies, some more, some less, are becoming very sensitive to these points. On top of that, flying has not become any more comfortable. By and large, I would say the one exception is, of course, the Airbus 380, of course. But it's not become very comfortable. So there are plenty of challenges here. I mentioned some of them. I mean, the open rotor technology, that is probably very good in reducing fuel burn very significantly, but what about the noise? And some trade-offs need to be made here. So much of that, at Airbus, I remember the figure, 90% of our R&D is focused on environmentally friendly flying or reducing the impact on the environment. That, I think, is a big story. If we ignore that challenge, I think we will get our license to fly, well, maybe not renewed or maybe more restricted than is today the case.
You also said that you talked about 3D printing and new technologies, but you also said that the innovation cycle for in aerospace could be up to 20 years. How do you safely introduce new technologies that are coming into such a long innovation cycle? Does that not bring added risk in the process?
Yeah, no, that is clear. I think we're not yet master that. We need to go in the direction where we think in more modular terms. I mean, it's a big thing. Remember, look at the re-engineering that we are now doing with 320, and then also Boeing is doing the same thing with 737. It's just re-engineering. But you touch so many systems on the aircraft that it takes a long time to develop the engines, but also to integrate the engines into the aircraft. There are so many things you need to do. So if we could come up with, and I guess obviously that's the not just the $10,000 question, that's the 10 billion question. If somebody could come up with a really convincing modular approach where you can more easily integrate new technologies, so that you don't have these obsolescence problems. The microchips are already 20 years old; nobody builds them anymore. That would be really a breakthrough, and that's a challenging commercial. I think in military, the customers are not yet, but the continuous improvement is something that we need. That we don't wait for ages or decades until a new platform comes out. That the platform is something that we can easily equip and re-equip with more modern, be it microchips, but also engines and other stuff. Here, I find our industry is still too inflexible. And by the way, I mean, not
Here
pick.
in the UK?
No. In our industry, in our industry. No, there's no new UK. I mean, we're so closely interwoven. That is a European or international. This is not just European. This is an international feature of our industry.
Mm. And so John mentioned I'm from BSI, and so I work a lot with Dean in Berlin, and they said that you were a keynote speaker at their annual meeting recently. So that clearly means you have an interest in standardization. But I couldn't help asking how you saw the role of standards in aerospace driving innovation. Do you see that as an important part of the process?
It's an important part of a process, but it can also be a big hindrance. I think not exactly standardization, but the whole certification processes, etc. If you ask our people today, why does it take so long to develop a new helicopter or a new aircraft? I mean, the bureaucratic, let's say, requirements for certification are probably 10 times higher than they were 20, 30 years ago. So it's huge. Yes, we need this certification of an aircraft. It needs to be really fail-safe. I mean, it's more important than a car. The engine stops, you don't fall from the skies or something like that. But we are in danger of being suffocated by too much standardization, but too much bureaucracy also. Standardization is a great tool if it can really clear some thrusts into the jungle, so to say. But we have a huge bureaucracy out there, and this is not to criticize unduly EASA, FAA, and what have you, but at some point, rather than inventing ever new rules and regulations, one would like to see that some of them get weeded out.
We'll take that away as my own action.
But it's also, let me say, attitude, mindset. You know, I spent a lot of years in the military, and I was used to, we have famous examples, Nigel, Eurofighter. You know, 20 years ago, 30 years ago, some smart guys got together at the very outset of development and asked the question, what wonderful new gadgets can we build into this aircraft? The question was not what does the Air Force need, but what can we build into that? And when the aircraft was flying, we discovered a few things. We said, damn it, why do we have it? Well, this was decided 20 years ago. It's you can't take it out again. I discovered similar attitudes also in commercial aviation. When the customer at some point, I won't quote anybody here, but comes to you and said, what is that? That makes my maintenance much more complex when it should be. I never asked for that. Well, the answer is quite often brilliant engineers have thought something out and didn't spend a thought on what the value would be for the customer. So to have engineering much more customer-oriented right from the start, I think is very, very important. We started at Airbus to send our young engineers, for instance, in the early years into the airlines, into the maintenance shops. Say, see what you do to these airlines when you design things too complex, maintenance intensive, etc., and then to come back with this customer orientation in mind and develop new great things for the industry. I think that's very, very important that engineers, that certainly doesn't account only for aerospace engineers, early on also see the end of what they're doing, i.e. the end customer, and how their great inventions impact the customer's operations.
You mentioned Neil Armstrong, Chuck Yeager, a number of names. Did you have a role model as an engineer? Did you have a role model that drew you into engineering?
No, well, I'm not an engineer. I'm fond of that, but no, I didn't have a role model. But I was very happy that I knew Neil Armstrong very well the last 10 years. Chuck Yeager, and yes, these people are absolutely amazing because they took huge risks that our test pilots today would certainly not even touch.
I love that idea of him just bouncing that spacecraft over the last few rocks to land it with 10 seconds of fuel.
Yeah.
Tom, finally, just a final question. You had a very nice line right there at the end about risk must be managed, but risks must be taken. What's the next big risk you see for the engineering profession?
Well, the next risk, I don't know, it's a risk. I see that as an international company that is globalizing also as a big opportunity. Maybe some people see that from a national perspective as a risk. I see it more as an opportunity. That's opening up to these great people in Asia, in other parts of the world, these young kids that are eager to become an engineer, to grow in these jobs, to join companies like ours. I always had the impression when I was the CEO of Airbus and I ventured out, went to India and China, and I love to discuss with young people in our engineering centers, be it in Bangalore or be it in Beijing. And they were amazing kids. I mean, not that we don't have amazing kids over here, but you have the impression the fire burns much stronger in these people. It's not surprising. They come from down, and they see huge opportunities here. And I think one mistake we must not make, and that is something where we also need to educate our politicians, is to close the doors and say you need to manufacture, you need to develop only over here. And the times are gone where these young Indians or Chinese or Indonesians would come to Europe and work here. We have to go there now, and with today's communications, it's not a big problem. I have put, for instance, we have at Airbus we created an innovation cell a couple of years ago. The innovation cell was not to provide technologies for the next aircraft. These are the guys who are supposed to look 20, 30 years really over the horizon. So the next after next generation of aircraft. And my people came and gave me that concept, and then they had a map on the front page of that concept paper. It was the good old map of Europe. And I said, you got it all wrong, guys. You tell me you want to look out 20, 30 years more over the horizon. That should not be the map of Europe. That should be the map of Asia. Yes. And I decided to put this innovation cell not into Europe, but into Bangalore. Yes. Oh, yeah, we have subsidiaries in Europe, but the core is in Bangalore because I want our people to think the future from the customers, particularly in this area. So, I mean, going back to your question, I think that's a big challenge, but I see it as a big opportunity for us to open up to talents in other countries and other parts of the world. But there's an intrinsic, not contradiction, but tension between our national policies and national governments and international companies who have to undoubtedly go this way.
Well, what a great note to end on. Tom, thank you very much indeed.
Yes, sir. Ian.
Okay. Would you mind giving your name as well as and when you come?
Ian Taylor, Chairman of Living Planet. Just a point. You didn't mention the space industry, which given that you've got satellite technology and Austrian as part of the EADS, I think has a more rapid innovation and deployment both in technology and in material science. My question is, why is EADS and the other aircraft manufacturers not taking a more constructive part in the debate about airports? I mean, the whole debate in the UK, for example, about Heathrow, is driven by historic views of what an aircraft is, its fuel efficiency, its environmental comparison in fuel efficiency with trains which are still using fossil fuel to drive their basic energy. I don't hear anything about new engines, new ways in which the aircraft industry itself could justify new airports near urban areas.
A good point, but let me first say I have to apologize. I'm already a couple of months out of my old job at Airbus, but obviously my memories about these Airbus examples are still very vivid with me. You're right. I mean, the space industry certainly needs to be mentioned as well, and these guys are doing a great job against all odds of the customer organization, if I may say so. The way they obviously work in many instances through EASA, through Just Retour. It's sometimes amazing that they get something done into into the orbit, particularly talking about Galileo, which finally seems to take off. That, I mean, I say that seriously. That is not so much due to the, or not at all due to the inability of industry. It has to do that we're operating here under structures, contractual structures, say just retour principle, that make it very difficult to get something done. And that, by the way, is a huge task, I think, also for the space industry going forward. As much as we need multinational projects, we need to find a way to contract more efficiently and to operate more efficiently, i.e., one contractor on the government side and one contractor on the industry side, I think, would be ideal. Up to airports, we're doing a lot already. I mean, not so visible because we are not in the front line of that, but we're working very closely with airport authorities. We are working with air traffic authorities, etc., particularly in the context of Brussels, with single European skies, etc., because we have realized, all manufacturers have realized, that if we don't get more efficient air traffic control, more efficient airports are part of it, when all our growth projections for the next 20 years, 28,000 aircraft to be sold in the next 20 years, will go up in flames, because it's just not happening, because we get choked at airports, at regulations, and at air traffic control. But I take your point. Maybe we need to engage more strongly, at least with the major hubs, Heathrow and Frankfurt and de Gaulle and stuff like that.
Hello, Andrew Parker of the Financial Times. I wonder if I could tempt you back to the talking points of combination, and whether you could spell out a little bit your red lines potentially in this deal. So, on 2 points. Number one, could you accept a government holding a stake in excess of 9%? And secondly, in your quest for normalisation, could you tolerate governments having anything beyond the golden chair that would block a takeover? In other words, could you accept a government having nomination rights or additional veto rights over strategic decisions? Thank you.
Andrew, nice try, but here's my red line. I hope you all understand the situation is very fluid and very advanced, and I'm not going to, in public, make any statements about any red lines or specifics for nominations. But I can understand that you couldn't resist to ask that question.
The risk of being cheeky, could I just come back on that by saying, you alluded in one of your early answers, you were saying the idea of going to slash thousands of jobs, and then forgive me, I couldn't hear the end point. Is your broad point
this deal is not about extracting large cost synergies from the two companies by them combining?
Well, you can give yourself the answer. I mean, these two companies are largely complementary. Yes, there are cost synergies that are in the usual areas of procurement, for instance, and in some other fields. But this will not go down in history as the deal with the most cost synergies we could extract from that. That's pretty clear. The strength of this combination is in the areas that I mentioned before.
Yes, sir. Next down on the left.
Chris Eady from the Welding Institute. Dr. Enders, I'm delighted that you highlighted apprenticeships and internships as valuable pathways to bring new talent into engineering. And we know of many large enterprises that have engaged in schemes that support that. However, you also talked about the extensive supply chain in aerospace, and it exists in many other engineering sectors as well. And many of the smaller and medium-sized enterprises don't engage in those because perhaps of the risks that they see in doing so. I welcome your thoughts on how large enterprises might encourage their supply chains to take up those pathways.
To take up apprenticeships and internships
to bring new talent in.
Well, familiar in detail how it's working in the UK. I can say, for instance, in Germany, we have a lot of apprenticeships also exactly in the smaller and medium size enterprise. What I would like to say in addition to that is that I think what we need is more partnerships also between the smaller companies, the suppliers, and the OEMs. Also precisely because we have a certain expertise at the OEM level. We are subcontracting today much more than we did perhaps 10 or 20 years ago. So again, like I said before, in the commercial aviation, young engineers to go into the maintenance of the airlines to see what brilliant engineers can do to disrupt the operations of the customers. No, you should see. We should also have more partnerships, and we started that in our company some years ago. Admittedly, it's not like it's a all-comprehensive scheme, but to discuss and agree with some trusted suppliers an exchange of younger people back and forth. But the back is important. You want them back at some point, not just to have them. So that, I think, is also a great way beyond apprenticeships and internships to share knowledge and exchange knowledge. I think it benefits both. It benefits the big companies and it benefits the smaller companies. This is a bit complex, and we haven't done that in the past. Usually when we lost somebody, we probably wouldn't see him or her again. But some of the smaller and medium-sized enterprise I find receptive to the idea, and we're trying to build an exchange here.
I wonder, is there a facility to take a question from next door? Could you work on that whilst we take a question here? Sir, the grey-haired gentleman, very distinguished looking.
Howard Wilden from EADS. Tom Mackay, say this to you, government's under enormous pressure in terms of what they can put in investments. Their pressure is to take out cost. What is, in your view, the future balance that we should look to in terms of investment from government in relation to investment from the private sector? The balance clearly isn't right at the moment. What do you see? How do you see the future going?
You mean in the aerospace industry overall?
Yes, in the aerospace and obviously defence is something rather different, but in the aerospace industry.
Well, I think we've seen over the years when you say defence is something different, but at least in the commercial area, that the governments are investing, I would say, less money into the sector than they did probably 20 years ago, 30 years ago. Airbus is a very good example. Airbus today is a very viable, financially viable entity. Yes, we still get government support in the R&D field. We have reimbursable loans, but our competition out there has a lot of support and subsidies as well. If you strip this away, I think the R&D support that we are getting today is much more efficient, also in terms of spending taxpayers' money, than 10 or 20 years ago. Why? Because at least gradually we have managed to find some coordination between the various governments. Whereas some years ago, every government wanted everything, and all the hot topics, be it carbon fiber, etc. We have managed, at least for our piece, for Airbus, to coordinate more or less 4 governments a little better than before. I'm not saying it's perfect. That is to say, it's stupid. You spend national money on all the same things. So let's spend it in the UK on things that are particularly pertinent to wings. Let's spend it more cockpit-oriented in France, and so on and so on. So that is a job also for industry to make government investments more efficient. And I think it takes not just companies who are operating across the borders, but it's very, very difficult because our national decision makers are just national decision makers, and not surprisingly, we're looking for the national good. But what I've found over the years at Airbus, I found encouraging that you can drive governments to coordinate their investments. That, I think, is at least one way to address the issue of lacking funds and lacking funding in the future.
Yes, sir. On my starboard side here.
Do I need a microphone?
Yes, I think you do. For the benefit of next door.
Tim Heath from Reuters. Tom, thank you. As a point of principle, do you think that it's possible to have normalised governance without normalised financing? And specifically, do you think that as you push back government involvement in the aerospace industry, that we could expect to see EADS moderate its appetite for government loans?
Well, look, I mean, one thing, Tim, I think we all agree on. In our industry, in the aerospace and defense industry, we have multiple relationships with the governments. Yeah? In defense anyway, as customers, but also in the civil area. By the way, there's absolutely no difference between over here in Europe or in North America. The disagreement is that some people in Europe still think that this industry should be partly owned by government, and nobody is thinking about that in the US, and I think also not so much in the UK. Yeah, but that we have multiple government relationships, R&D funding, export regulations, etc., CFIUS in the United States, that is pretty obvious. So what are you hinting at, Tim?
Well, I'm saying if you don't want the governments in your company, why are you still asking them for what the Americans call launch aid and what you call reimbursable loans?
Tim, I think again, look at the Americans. The American government is not thinking of investing into shareholding in any of the big companies, but they are recipient of multiple funding streams from the government, federal as well as local. So where's the point?
Would you distinguish between equity and other funding methods? Couple more questions. The lady.
Thank you. Hi, Tom. Sophie Sassad from Reuters. Another Reuters journalist.
Another question from Reuters? Can we take this quickly, because I think there's some other engineers watching.
Okay, be quick. So it's the burning point again. I'm sorry about that. I was just wondering, how are you addressing your shareholders' concerns, and especially those like Arnaud Lagardère, who seem to have very immediate financial concerns?
Well, look, is that something specific? Shareholders are obviously always financially concerned. I mean, they invest to make money, and so it's absolutely not surprising that some shareholders are concerned about the benefit or the return they are getting. I find that not spectacular. I think Mr. Lagardère put out a press release this morning that was, I wouldn't say unfriendly, but was just stating the obvious, that he wants to see the benefit return from this merger. We've had a lot of investors, we met a lot of shareholders in recent weeks, and we're discussing pretty much the same question with them.
Yes, at the very back.
An engineer, please.
Hi, sorry to disappoint you, I'm not from Reuters and I'm not an engineer. I am ex-City, so left the financial sector. Simon Jones, I'm pleased to hear you discuss Concorde a lot in your presentation. I'm actually planning to put on a big exhibition at some point, hopefully next year, about Concorde, because for my sins I've spent some City bonuses on things like the Concorde nose cone, undercarriage, and what I'm planning to do with it actually is to try and inspire the next generation of engineers, designers, and innovators. My father was in the chemical engineering sector. That's probably where I get my fascination with engineering from. His heroes are people like Isambard, King, and Brunel. So what I'd also like to do is look forward to looking back 50 years. In fact, I just came from Lancaster House, where they signed the Concorde Agreement in 1962, 50 years ago. Fascinating place and such history. And it really, I think Concorde was the time when, Europe came together to build great projects. So, I think it's the foundation of Airbus and, a lot of cooperation between European industry. Looking forward, if I take my exhibition, what I want to do is dig back 50 years and what we learned from Concorde, distill the lessons out of it, but also then look forward 50 to 100 years, actually, to the point 2100. So much beyond what you were saying, with the next 20, 30 year horizon. So if we specifically, just a quick question, I guess, on hopefully I can have the support of the EADS at some point in that, part of attracting the young engineers, but just some thoughts on moving forward, how do we master the physical movement of people, let's say from London to Australia, which now takes, I think, 24 hours still. We've mastered the data transmission, in light speed, with Skype and things like that. But just some thoughts, please, on looking way far ahead and what the EADS is working on with hypersonic and supersonic.
Well, thank you very much. We have indeed some of our innovation works people, and some of you may have seen that in the exhibition we had in in Farnborough, and last year I think it was also in Les Vosges, about supersonic transport. We have a wonderful model, but that should not be mistaken as meaning that we will fly the first full-scale plane in a couple of years. When we're doing basic technology work on supersonic travel, we have a partnership with the Japanese, quite interestingly, since many years, where we're also doing research on supersonic travel. But before that becomes a development program, I'm afraid I might be out of office, John. Can I say that?
You never can tell. If there's an engineer in the house who would like a question, this is the last one, but you've got to be a fully fledged engineer and give your qualifications when you stand up. Anybody willing to take the chance? This gentleman here.
You predicted that it would be 100 years between the first B-52 flying and the last finishing flying. During this time, the B-52 platform probably doesn't change very much. How many generations of quite distinct avionic capability do you expect in this 100 years?
How many generations?
Of avionics.
Of avionics. Well, I mean, if I guess our joint vision of having modular avionics, which we are playing with or implementing in military, if that really comes to fruition, I think it will be very difficult to talk about different generations of avionics, because we should be able to change and modify avionics or certain avionics when they come online. So the whole concept of modular avionics will, I think, not be measured in generations again. So we will see much more, a bit like in the communications today, iPhone 4, iPhone 5, etc. But for that to happen, we need to make huge progress also on the cost side. I mean, the way we're selling avionics today, no airline and no military customer can afford to update his avionics every couple of years with the prices we demand today. We'll have to see huge cost decreases and huge progresses, I think, also in manufacturing.